we are just going to quickly review the two types, single and double displacement. When you displace something, you are going to essentially switch or replace it. So the general rule for elements displacing each other, whether it's single or double, is like displaces like. So metals replace metals, non-metals replace non-metals. And if you have been really sort of thinking or taking home the idea that you're making often ionic compounds that are plus and minus, then this makes sense. If you take a metal out, then you need another positive item to go in, okay? So it's really about a plus replacing a plus, or a cation replacing a cation, anion replacing an anion, okay? So again, in grade 10, you probably just had to state the type of these. Whereas this year, if we get time today, predicting the products of single and double displacements are their own lesson, okay? So these, whether it's single or double, then the these general guidelines will be helpful. So we're going to treat hydrogen as a metal. So it's going to be positive, like we've been doing. Same thing with acids, which we've been also doing, treat them like ionic compounds. So then you have like hydrogen is the positive and then whatever's the anion. And then of course we just talked about this one, treating water like HOH. As I said, for the rest of your chemistry lives, that's going to be a helpful thing to remember. And I know it's weird because we're used to thinking of water as a polar covalent substance, or something that we just dissolve items in, but really it's got a lot of applications and a lot of presence in different kinds of reactions. Okay, so we're just going to look at stating the type right now. So probably your grade 10 teacher focused on the first type, which was metal replacing a metal. So here we have sodium, which is a metal, and copper. Even though copper is a transition metal, that doesn't matter. So then now the sodium is going to take the place of the copper. So again, you need to make a new ionic compound. So in the product, now we have a plus and a minus. That's our new ionic compound. And the metal goes by itself. Maybe you were shown this. We're also going to look at what happens when you have a halogen. So halogens in general are a pretty reactive anion because they only have to lose one valence electron. So they actually will participate in single displacement reactions as well. So again, this one is usually okay. Usually students are okay with this. For this one, you're going to want to make a new ionic compound. So this is plus and minus. So fluorine by itself has a 2, but you're going to make a compound. So here's chlorine inside the compound, and then they switch. So now fluorine is the anion and the chlorine is by itself, okay? You're not going to put the chlorine and the fluorine together. That's two minuses together, opposites attract in chemistry. So this one, and we're going to do, again, a whole lesson on this, but this one maybe you weren't shown in grade 10. Okay, so for double displacement, there's lots of general formulas. Grade 10 teachers love the dancing partners. A boy and a girl are dancing, and then another boy and girl are dancing, and the girls switch places. It's a terrible analogy, sort of, and kids are always like, ha, so-and-so's dancing with so-and-so. But really, it does really work because like has to displace like. So you need the cations. So in this case, this example, I've said A and C are cations. So these two here. And then they have to switch. It doesn't matter which product you write first. like you could have written AD and then CB. That doesn't matter. So then B and D are the anions. So you need to make the plus minus, plus minus, plus minus, plus minus. So you always have ionic compounds. However, the ionic compounds must be aqueous. And that makes sense. If you had two solids sitting on the counter, then the chance of them reacting together, what? That's not going to happen. Okay, so the ions must be separated in order to switch places. So when we do the double displacement lesson, we're going to write AQ, AQ, and then we're going to figure out which of the products is solid and which of the products is aqueous. Or even a gas, okay? That's the trickiest kind. So that's what we're moving towards, okay? So neutralization is a type of double displacement reaction. So we love sodium hydroxide and hydrochloric acid, right? We love that one. So again, when you do neutralization, you've got plus, minus, plus, minus. So then if you think of water like HOH, you can see how you get HOH. Okay, so now it doesn't matter which one you write first. Most of the time people will say neutralization, acid, base, salt, and water, but it really doesn't matter. So, but I'll write the salt first. So now the sodium will switch with this positive. So you get NaCl, plus minus. This is the most common one too because they're plus one, minus one, so then they switch and you get the same thing. And then you get HOH, which is water. And lots of times students will say to me, well, Ms. Todd, can't I just write H2O? Sure you can. However, if to get yourself used to it, maybe in this note, write it as HOH, so you get used to thinking of water as an ionic compound with a positive and a negative ion. So the homework is really for this is really just one simple question. Is a single, like it's like just stating the type, so easy. And